Let's say if we have 1 plus 2 plus 2 squared, and then 2 to the n minus 1 is equal to 2 raised to the n minus 1. Let's test it out with a few numbers. So let's see if it's true when n is 1. So the first term is 1, and on the right side, let's replace n with 1. So that's going to be 2 to the first power minus 1. So that's 2 minus 1, which is 1. So it's true when n is 1. It's true for the first term. Let's see if it's true for the second term. So we need to add the first two terms. So that's going to be 1 plus 2, and then let's replace n with 2. So 1 plus 2 is 3. 2 squared is 4, and 4 minus 1 is 3. So it's true for the second term, or when n is 2. Let's see if it's true when n is 3. So on the left, let's add the first three terms. So it's going to be 1 plus 2 plus 2 squared. And that has to equal 2 to the third minus 1. 1 plus 2 is 3. 2 squared is 4. 2 to the third, that's 2 times 2 times 2, which is 8. 3 plus 4 is 7. 8 minus 1 is 7. So it's true when n is equal to 3. So we're going to assume that it's true when n is equal to k. So we're going to have this expression 1 plus 2 plus 2 squared plus 2 to the k minus 1 is equal to 2 raised to the k minus 1. Now, let's prove that it's true when n is k plus 1. So the next term, replace k with k plus 1. So it's going to be 2 k plus 1 minus 1. And then replace this k with k plus 1. So we need to prove that the left side and the right side are the same. The first thing we need to do is replace this expression with 2 raised to the k minus 1, because they're equal to each other. So we're going to have 2 raised to the k minus 1 plus k plus 1 minus 1. The 1's cancel. 1 minus 1 is 0, so that becomes 2 raised to the k power. Now, how can we show that the left side and the right side are the same? Well, imagine if we set x equal to 2 raised to the k. This would be x minus 1 plus x. And we know that x plus x is 2x. So we would have 2x minus 1. And then if we plug it back in, if we replace x with 2 raised to the k, it would be 2 times 2 raised to the k minus 1. So that's what we now have at this point. Now let's focus on properties of exponents. So let's say if we have x squared times x cubed. When you multiply by a common base, you can add the exponents. X squared times x cubed is x to the fifth. So 2 to the 1 power times 2 to the k is 2 raised to the 1 plus k. Now 1 plus k and k plus 1 are the same. If you add 3 and 5, or 5 and 3, both ways you still get 8. And so that's how we can show that the left side is equivalent to the right side of the equation.